Hello, students. Today we're going to look at a question from the 2018 state biology test. The reason I've separated it out is because it's kind of lengthy, so I thought I'd do a separate video on it. The map shows the geographic distribution of salamander subpopulation that descended from the common ancestor E. organolensis. Over millions of years, the salamanders moved south from what is now Oregon and Northern California into areas to the east and west of the California Central Valley. The salamanders were initially separated by a large lake and later by the unsuitable habitat of the Central Valley itself. Because of this geographic barrier, gene flow among some of these subpopulations is extremely limited and in some cases has led to reproductive isolations, which you know when you hear reproductive isolation, you're going to become a different species. So let's look at our map here. We have the founding salamander, whose population got separated. Over to the west, we have salamander L and salamander N. Over to the east, we have three salamanders, M, O, and P. P is on the west side of this divide. Keep that in mind as we do these problems. This salamander question has three parts to it, 6, 7, and 8. So let's look at 6. Based on salamander distribution data shown on the map, choose two salamander subpopulations between which gene flow can occur. Move two salamander subpopulation labels into the blank boxes. Move only one salamander label into each blank box. There may be more than one correct answer. So to have gene flow, you got to be in some kind of contact with your fellow salamanders. So in this case, if we look over here to the west, we see L and N can have gene flow, right? That's a correct answer. Remember, there can be more than one correct answer. Look over here on the east side, we have M and O can have gene flow, okay? Another correct answer could be O right here, and P could have gene flow. So not really a hard question, but interesting. Question number 7. Which two salamander subpopulation would be least likely to reproduce successfully if brought together? So we have L and M, which is at the top. Again, they're on separate sides of the divide. We have L and N. Well, there's a gene flow there. Let's look at D. P and O. Well, they're on the same side of the divide. There's a gene flow there. The correct answer, in other words, we've got to remember, which would be least likely to reproduce if successfully brought together. That answer has to go to P and N. Why? These two species are geographically isolated and have been diverging for the longest time from already two unique subpopulations. So in other words, they've been having the divergent the longest time. Question 8 has to do with us completing this cladogram based on this map over here. So this shouldn't be too hard, right? So we got to find the ones with the closest common ancestor. And since we have 2 here and we have 3 here coming off, I would say this side, L and N, would be over here. L and N, okay? And then the next one to the founding would be M. And of course, O and P would be close, right? They'd have a common ancestor. So there you go, your cladogram. Not very hard, right? L and N would have a close common ancestor. O and P would have a common ancestor because O, P, and M would all have a common ancestor here. Okay. I hope you enjoyed the salamander problem. It sure is fun, and I'll see you next time.